In this video, I'm going to talk about the collisions lab and how to do the data collection for this particular lab. Now, the first thing I need to do if I look at the instructions is take the mass of the cart and any weights I want to add to the cart and enter it in my data table, and I've already done that. There are two carts I have, one is blue and one is yellow, and I'm always going to be pushing the blue cart toward the yellow cart in this experiment. So the yellow cart was always initially at rest, and the blue cart is the one that I push initially. Now, depending on which one of these trials I'm doing, there are three different collisions it asks you to do. One of them, the carts should push off each other without actually touching. This should be elastic, which means that both momentum and kinetic energy are conserved. There should be one where the carts actually physically bump one another, but move differently after the collision. And the other one is where they run into one another and stick together after the collision. That last one should be our completely inelastic collision. So the first thing I need to do is to set up graphical analysis to collect the data that I want to collect. So I'm going to pick graphical analysis. We're going to pick my sensors, and I'm actually going to pick two different carts this time. So I have these two carts turned on. There's my yellow cart, and we're going to let connect. And then we'll do the same thing for the blue cart. And we'll let it connect. Now, the only sensor I need on these carts is the position sensor, because all we're really concerned about is how fast the carts are moving both before and after the collision. So I'm going to hit done, and I'm going to do one other step here to make it a little bit easier to see what's going on. And that other step is to switch to just a single graph and make that graph just the velocities of the cart. Really, all that I'm concerned about is the velocity of both carts before the collision and the velocity of both carts after the collision. So the next step, I'm going to line up my carts on my track. I want to make sure that positive X points in the same direction. That way both carts see the positive direction as the same direction. And then I'm going to hit collect. And once I hit collect, I'm going to push the blue cart toward the yellow cart. And we see that we have a collision that occurred, and the velocities of the carts change. So where my collision's actually occurring is this region in here, when the velocities are changing. So if I want to find the velocity of the carts before the collision, I'm going to go way back here to where the yellow cart isn't moving. So I'm going to pick maybe that point right there. 0.344 is the velocity of the blue cart. So the velocity of the blue cart before the collision, 0.344. And then the second thing you need to do is to figure out how fast the carts are moving after the collision. So if we look at, here's the collision happening. Oops, sorry. It looks like right about in here is where the collision stops happening. So I could pick either one of these. Let's just pick that one there since the blue one changed a little bit more. So the blue cart afterwards is moving negative 0.079. And then my yellow cart's moving 0.252. And so that's how I collect the velocity data for this lab. I'm going to create a separate video to talk about the analysis, how to get momentum and kinetic energy out of this, and how to answer the question, is momentum conserved and is kinetic energy conserved? How to answer those questions. Now, when I switch from one trial to another, what I end up doing is changing which bumpers are on which side of my cart. So I'm going to switch to one where they stick together during the course of the collision. So what I'm going to do with both of them is switch the magnetic bumpers with the Velcro bumpers. And I should have two Velcro bumpers which will stick together, just like I should have two magnet bumpers which would have repelled one another. So there, I've made the switch. And now I'm going to get ready to collect my data for this second trial. Now here I've set it up so they should stick together. So I'm going to hit collect, push the blue cart, and there we go. It looks like they stuck together. So again, here's where my collision's occurring. It looks like they're moving together after the collision. If I want to know the speed before the collision, I'm probably going to pick, say, this point here. So the blue cart is moving 0.639 after the before the collision. And then after the collision, we're going to pick when do they start moving together. Oh, 0.238, 0.239. And there we go, I've collected the data for that one as well. So that's how I collect the data for this lab and what I'm going to be looking for in terms of finding the velocity data.